So we went on the freeway, and every 12 seconds we recorded the speed or velocity, and we did this a total of 15 times, adding up to 3 minutes. We converted our velocity or speed from miles per hour to feet per second. So this is our left-hand sums, and these are our right-hand sums, and our area for the left-hand sum is 18,129.152 feet. And then the area for the right-hand sums is 18,445.961 feet. And the average area is 18,287.557 feet. And that is equivalent to 3.464 miles. Therefore, the significance of the area underneath the graph is equivalent to the distance traveled in feet.
The odometer started at 97,258 miles and ended at 97,262 miles, giving us a total difference of 4 miles. Even though the average that we took was 3.464. This is okay because the odometer didn't necessarily start on 97,258.00. It could have started on 0.05 or something along those lines, which would given us 4 miles instead of 3. Using our right and left hand sums and the total area under the graph, which is the total distance traveled, we can find the average velocity by taking the area on the graph, which is the total distance traveled, and dividing it by the time span in which we drove. Our average velocity was 101.598 feet per second, or 69.28 miles per hour.
So you can apply the same concept that was used in this project to, say you are working in some sort of production or manufacturing business, and you wanted to measure the quality of employees you have. So you can measure the efficiency of the workers rather than, say, the speed over time that was measured in this project. So if you were to change velocity to production, and your units would change from feet per second to, say, the units produced per minute, you could determine which workers were the most valuable to the production line, which were the least valuable. So down here, if over a span of several minutes you pulled out one worker at a time, and then in the next several minutes you put in that worker and pulled out a different worker until you had done so to all of the workers, you could measure which ones were the most valuable and least valuable to the production line. For instance, you'll see here that production is the highest when X worker is pulled out, so therefore that worker is the least valuable because the production is still so high. On the contrary, over here you'll see production is lowest when this worker is pulled out, which means that worker is the most valuable because he or she leads to the highest amount of production. Also, you can use the area that we use to find our distance traveled. You can use that area to find the total production of units, and using that total area you can figure out, using the graph, how you can maximize and minimize your total production.